Hello and welcome to my tutorial in Java. My name is Todd. In this lesson, we will have discussion about data types in Java. More specifically, the following topics will be discussed. First, we will define data. Then we will see data types. After that, we will have discussion on primitive data types. And finally, we will see reference data types. Alright, let's start. What is data in programming? Data in programming refers to a collection of symbols, alphabets, numbers, or characters that are stored and processed by computer for producing output as usable information. Data is represented by byte that is in turn composed of bits or binary digits that can have the value of 1 or 0. For example, if you type this address, how will the computer store it? The computer will save this data as zeros and ones like this. Let's see another example. Let's say your name is Alex. How will the computer store it? In the computer, it will be stored as zeros and ones like this. What if you type double hashtags? Again, in the computer, it will be saved as ones and zeros like this. What if you type a character like this? Again, it will be saved as zeros and ones. Therefore, as we have seen in our examples, data is a collection of symbols, numbers, alphabets, characters that are represented by bytes that can have a value of 1 or 0. Data types in Java. Data type in Java refers to classification of data, such as symbols, objects, numbers, or characters. Different types of data serve different purposes. Why classification of data is important in Java? Classification of data is crucial in Java for the following reasons. Number one, to tell the compiler how much memory space to allocate or to determine the size of memory. Number two, to tell the compiler how to store the data. Number three, to decide on the type of the operation that is going to be performed, such as arithmetic operation, comparison, or concatenation. Number four, to tell the compiler about the range of values. Java has two kinds of data, and these are primitive data types and non-primitive data types, or reference data types, or object data types. Let's see each data type one by one. What are primitive data types? Primitive data types are predefined data types which are supported by Java. Primitive data types store the value within themselves. Primitive data types come with a number of predefined operations. Java has 8 primitive data types. These are byte, short, int, long, float, double, boolean, and char. Here's what I want you to keep in your mind. Primitive data types cannot be broken down any further like reference data types. Let's see each primitive data types one by one. Byte, short, int, long, they all are integers data type. Whereas float and double are fractions. They store decimal values. Byte, short, int, long, float, and double, they all are numeric data types. Whereas char, it stores characters, single characters like letter A, letter B, or letter C. And when we have true-false values, we use a data type called Boolean. Let's see the size of memory consumptions. Byte consume 1 byte, which is about 8 bits. And the maximum value that can be stored in byte is 127, whereas the minimum value is negative 128. If we have a value which is larger than this, then we might save it in short. Short consumes 2 bytes, which is about 16 bits, and the minimum value that we can store in short is negative 32,000, and the maximum value is about positive 32,000. And when we have a value which is larger than this, then we'll go to int. And int consumes about 4 bytes, which is about 32 bits. And the maximum value int can store is about 2 billions. And the minimum value is about negative 2 billions. And when we have a value which is larger than this, then we will store it in long, and it consumes about 8 bytes, which is about 64 bits, and it stores around 9 quintillion, the maximum value, and negative 9 quintillion, the minimum value. Float, it stores decimal value or fractional values, and it consumes about 4 bytes, and it's about 32 bits. Double, it also stores decimal values, and it consumes about 8 bits, and it's about 64 bits. So when we need more precision, it's better to use double instead of float. When we have characters like letter A, letter B, letter C, then we'll store it in char. It consumes about 2 bytes, which means 60 bits. And the maximum value that we can store in char is 0 and 65,000, and the minimum value is 0. And Boolean, it stores true and false values. It only consumes 1 byte of memory. Please note that integer data types can hold whole numbers only, such as 25, negative 67, 64, and 74, and 84, and so forth. Byte, short, int, and long, they all are integers, as I've said it earlier. One integer differs from the other only by the size. For example, the range of the value that can be stored in byte is between negative 128 and positive 127, as we have seen in our previous table. But the range of value that can be stored in short is from negative 32,000 to positive 32,000. Let's see a small program in Eclipse. Let's launch Eclipse and let's create a new project, new Java project. And let's call this project as print. And let's hit finish. And now let's create a package within this project. And let's call this package as, or let's call it pack. And let's hit finish. And let's create a class within this package. And let's call it pClass. And let's include the main method in there. And let's hit finish. And let's get rid of this because we don't need it. And the first data type that we will see is byte. I have already created the program, so let me just copy paste that. So the first data type that we will see is byte. You can see byte stores 100 right here, and this line of code prints the value. Let's see another variable that is short, and short stores 23,000. Let's see int. Int stores more than this value. It's about 50,000. And you can store up to 2 billions in int. If you have a value larger than 2 billion or int, then you can store it into long, like this. But we need to put letter L, uppercase letter L, I prefer, at the end in order to indicate that this value is long instead of int. And this line of code prints the value. And when we have fraction or decimal value, we can use float, And at the end, in order to indicate that is a floating value, we put F. And this line of code prints the value. And when we need more precision, we use double and put the value like this. And this line of code prints the value. And the next data type is char. And if we want to store characters like letter A, letter B, letter U, letter C, whatever character that you have, then we use char. And we need to put in between single quotes or in single quote, inside the single quote. And this value will print out the character. And then if we have true false value, then we will store that value in Boolean. And then you can print out the value of Boolean through this line of code. Let's run this program and see. Here you are. All your results are printed out here. And as you can see, but we have declared 100 and we printed that out. In short, we have declared about 23,000, stored 23,000 and it's printed out. And in int, we have declared this much value, and long, we have declared this much value, and float, double, and characters, and Boolean. Now let's see the compiler reaction if we try to store a value which is out of range. Let's say, let me try to store 200 in byte. See, the compiler is saying the type is mismatch. See, type mismatch. Now let me correct the value and try to store 20. Excuse me. See, the compiler is now happy to store our value because it is within the range. If we would like to store 230,000 in short, then the compiler complains the value is way above that can be stored in short. So if I correct that, then it will happily store the value. So in short, this is how you play with primitive data types in Java. Now let's see arithmetic operations on primitive data types. We can use all basic arithmetic operations such as addition, subtraction, multiplication, and division on primitive data types exactly the way we have been using since elementary school. Example, if we want to use any of these arithmetic operations, we can write our program like this. Int a stores a value of 10, int y stores the value of 4, and int result is equal to the sum of a plus y. And by using modulus operators, we can get the remainder of a division, and which is denoted by the percent character like this. Example, int r is equal to 10 modulus 6, which will give us the remainder. Let's see example in Eclipse. Let's declare here, for example, if we have int a that stores 10, and if we have int y that stores 4, and then if we want apply all the arithmetic operations, we can do as follows: int result is equal to a plus, let's add first y, and then we can print out the result if we want. System add print ln, and let's put the sum is equal to this, the variable a plus y, and let's say it plus concatenation operator here, and let's put semicolon in here too. Let's run this program. See, the sum is 14. So if you want to multiply this these values, then the only thing that you need to do is change the addition sign into multiplication sign, that is asterisk. So let's put asterisk on it, and let's put asterisk here too, and let's say this, instead of the sum, let's say the product. The product is, and let's run this, and let's see the output. See, the product is 14. So 10 multiplied by 4 is 40. So the product is 14. If you want division, only change the sign right here. So let's change it, instead of asterisk, let's put forward slash. That's how division works. So let's put division here, and let's say here the result is, so that you can easily see that. Let's run it. See, when we divide 10 by 4, then the product, the result is 2, because we don't have the remainder here, because for the remainder we will have another operator called modulus. Now let's see the modulus operator. So let's put the percent sign here, and let's see the percent sign here. And let's run this. See, now the remainder is 2. When we divide 10 by 4, then the remainder would be 2. So this is simply the way how you use arithmetic operations on primitive data types. You can play with all these operators by yourself. Practice as much as you can. And now let's see non-primitive data types in Java. Non-primitive data types are not defined by Java, but they are instead created by the programmer. In Java, non-primitive data types are simply called objects because they are created rather than predefined. Non-primitive data types are also known as reference data types. An object in Java may contain any type of data. How do we create reference data types in Java? To create a reference data type, use a new keyword. For example, person, and then we have the variable and the new person, and semicolon. Let's look at a little further this example or the syntax. This person implies the reference type. St is the object reference, and person with parentheses is the constructor. And if we'd like to print out the value of this variable, then we can use this line of code, system.out.println, and the variable. And then it will give us this result. Let's see each section of this result. Then the first section is a package, and the next section is the class, and this is the reference or the address. Please note that the basic difference between primitive data types and reference data type is that primitive data types stores the actual values, whereas reference data types stores the address of the objects they refer to. While reference data type stores the address in lieu of the actual values, because different objects require different amounts of actual memory. As a result, it's impossible to know how much memory should be set aside prior to the creation of the object. So, the solution is to reserve working memory that fits for the types and the size of the object that will be created. Let's see example. Example, int y is equal to 99. Then y is a container that can hold 99 because y is a primitive data type. Whereas when you see the reference type here, person, s is equal to new person, s is not a container, but s indicates reference number or tracking number that is useful for knowing the physical location of the object. Let's see this program in Eclipse. Let's declare the variable right here, and int d or int u is equal to, we have u already, so let's say int r is equal to 87 and semicolon, and let's declare, let's say this person is equal to percent %p or percent %s, can say s, percent %s, new person, semicolon. Let's make this uppercase. Let's make this uppercase too. Let's see. Now, we should say this, we should put our class name here. So what is our class name? The class name is pclass. So let's say pclass. Let's say pclass. And we should put the same constructor name with the class. So pclass. And let's make it the uppercase pclass. And now we're good. And let's say s here. Let's put s variable s. And now let's print out this variable. Let's add the code that prints out the variable sy so control space enter, and let's put r here to print out. And right here, let's print out this variable too. sy so control space enter, and let's say s. And let's run this program. Let's run this program. Java is the compiler is complaining that the value of s say n, let's say n, and let's put here n2. And now let's run the program. Run it. Here you are. So here, when you print out the primitive data types, you get the actual value because primitive data types store the actual value. That's 87. But when we print out the reference data type, it returns the address of the variable instead of the actual value. Let's summarize. Primitive data types are predefined data types, whereas reference data types are created by the programmer. Primitive data types can hold the actual value, as we have seen in our program, whereas reference data type do not store the actual values, but store the address to the location and memory where the data is stored. Primitive data types are basic types of data, whereas reference data types are not. And reference data types are any instantiable class as well as arrays. And that ends my presentation on data types. Hope it will be helpful. Thanks for watching. Please check on my next tutorial.